Hello everyone and welcome to STEM School. Today's video is part 2 of the scientific notation topic. In part 1 I explained all the different concepts, so check that video out. But today we're going to do a variety of different exam questions for GCSE and Scottish National 5. So here's a brief summary at the top here of what I've done in the part 1 video on scientific notation. And the first example that we're going to dive into is very typical for a non-calculator paper. What we're asked is to write 6,005,200 in scientific form. So what we have to do is first of all write it in number form. So it will be 6,005,200. So that's 6,005,200. The next step is to get a whole number or decimal number that's between 1 and 10. So for this, it will be 6.0052. So don't be confused by the two zeros here, as we have two numbers after them, so they're included in that. So to figure out the power, what we need to do is figure out how many decimal points in 6.0052, how many jumps does it take for that decimal point to get to the end of the number. We use this to figure out the power. So we've got 1 jump, 2, 3, 4, 5, 6. 6 jumps equals to the power of 6, and that's the final answer. Now this question here involves multiplying with scientific notation. The question is simply asking us to multiply 7.5 times 10 to the power of 4 by 2.5 times 10 to the power of 3. So this is a calculator exam, so we can put this into the calculator and we'll get a big number, which is 1875, and we have 5000000. And as always, we have to put the final answer in scientific notation. So we need a number that's between 1 and 10, that's whole or decimal. For this, it will be 1.875. Now how many jumps for the decimal in 1.875 to get to the end of the number? So we start here, be 1, 2, 3, 4, 5, 6, 7 and 8. 1.875 times 10 to the power of 8. Simple as that. The third question that we're going to do involves dividing with scientific notation. So the question we have here is 9.12 times 10 to the power of 10, and that's all over 3.2 times 10 to the power of 4. Now you'll notice this is a calculator paper, so what we can do is just put this directly into a calculator, and what we'll get is 285 and 0, 0, 0, 0. Now we have to put the answer into scientific notation, okay? So what number is whole or decimal number between 1 and 10 for this? So we can say that we have 2.85. Now how many jumps does it take for the decimal in 2.85 to get to the end of the number? So let's do that. So we've got starting here 1 jump, 2, 3, 4, 5, 6. So 6 jumps means 2.85 times 10 to the power of 6, and that's the final answer. Let's move on to the next question, and the next question is stating that the volume of Venus is approximately 9.3 times 10 to the power 11 cubic kilometres, and this is 85% of the volume of Earth, and we're tasked with calculating the volume of Earth. So we can say that the volume of Venus is much less than the volume of Earth. Okay, so this question is simply using our knowledge from the percentages topic, okay? So we can use a percentage equation to figure this out. So what we can do is say that the volume of Venus divided by the volume of Earth multiplied by 100 is equal to 85%. Okay, so this 100 here is converting to percentage, okay? And so what we have here in the numerator, we've got the smaller volume, and then in the denominator we've got the bigger volume, okay? And that means when you times it by 100, you'll get something that's less than 100% because the volume of Venus is less than the Earth volume. So we just substitute all the values. So the volume of Venus is 9.3 times 10 to the power 11 kilometers cubed. Then we put that all over the Earth volume. And here what we can do is we've got times 100 on the left hand side, we can divide by 100 on the right hand side. So 85 divided by 100 is 0.85. So writing this 85% as a decimal. And then what we can do is 9.3 times 10 to the power 11 kilometers cubed divided by, we can put this earth volume to the right hand side and bring the 0.85 to the left by dividing, so be 0.85 in the denominator, and this, we put this into the calculator and then we can figure out the earth volume. So when you put this into the calculator, what you'll get is 1.094 times 10 to the power 12 kilometers cubed. Don't forget to put the units, okay? Now this is the final answer because we have a number here that's whole or decimal between 1 and 10. And finally, we've got another very common question for Scottish National 5. The question states that there are 3 times 10 to the power of 5 platelets per milliliter of blood, and on average a person has 5.5 litres of blood. On average, how many platelets does a person have in the blood? And you have to give your answer in scientific notation. So the process for this question is that we're starting off with millilitres, okay, and we want to figure out how many platelets are in 1 litre and then convert that into 5.5 litres. So the first step is to realise that there are 1,000 millilitres in 1 litre. So what we have to do is multiply 3 times 10 to the power of 5 by 1,000 to figure out 1 litre, okay? And since this is a calculator exam, you can put this into the calculator and what you'll get is 300 million platelets, okay? And if you were to convert this into scientific notation, we need a number that's whole or decimal number between 1 and 10 using this format here. So for this, it'll be 3.0. And then for the power, how many jumps does it take for the decimal in 3.0 to get to the end of the number? So we start here, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. So it'll be 8 jumps, meaning to the power of 8. So that's how many platelets are in 1 litre, okay, per 1 litre. Now let's figure out how many is in 5.5 litres. All we have to do is times 3.0 times 10 to the power of 8 by 5.5. And when you put that into the calculator, you'll get a big number. What you'll get is 1650, 000, and 000, okay? Now this isn't the final answer because we need to put it into scientific form, okay? Scientific notation. So it'll be 1.65 times 10. Then how many jumps does it take for the decimal? It'll be 1 jump, 2, 3, 4, 5, 6, 7, 8, 9. So times 10 to the power of 9 platelets per 5.5 litres. And that's the final answer. Alright guys, that's everything for today. I hope this video has helped you with your preparation for the exam. Do check out my next video as we'll move on to ratios. And as always, please do like and subscribe, and I'll see you in the next video.